Before we start this video, if you are new here, then please subscribe to my channel, turn on the notification bell, like this video and share it with those who want to learn analysis and design of RCC structure and steel structure. And if you want to learn AutoCAD 0 to Hero, then buy my ebook AutoCAD Not To Stay Beginner. I will put the link in the description box. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello civil engineers and welcome to CIVIL53. In the previous lecture, we talked about Staadpro interface and we did analysis and design of American Tower. In this lecture, we will do analysis and design of mobile tower. Why do we need to design mobile towers? Mobile towers are an integral part of our critical telecommunication infrastructure. In the past, we were limited by where we could communicate from and how. Now dispatchers can use software on a cell phone to send and immediately receive communications. If you have a cell phone, then you interact with mobile towers every day, even if you don't make any calls. Yet most of us do not realize how these critical components of our telecommunication networks work, nor do we realize the vital role these towers play in our daily life. Okay, now it's time to move over to Staadpro and start working. Click on New Project, select Space, Meter, Kilonewton, give it a name, Mobile Tower. Click on Next, Add Beams, Finish. And here it is. As we said before, the first thing we need to set up is the geometry. Let's open the PDF and see the geometry. So this is our PDF file and this is our mobile tower. As we can see here, the geometry is 1.4 meter, 1.5 meter. So let's get back to the Staadpro. Click on Edit, XZ plane, make it 1 by 1, and spacing we will make it 1.4, 1.4. So as we can see now, our geometry is ready. Now we need to connect them. So click on Snap Node Beam. Take your first point, left click, left click, left click, left click, left click, and press escape to exit command. So by this, the base geometry is created. Now let's open the PDF file. As we can see that. So this is our mobile tower and the total height is 16 meter and floor to floor height is 1.6. So that is mean we need to create 10 floors. First, we will create the first floor with pressing and then we will create the remaining 9 floors. So let's get back to the Staadpro. Select the geometry like this. Now click on Translational Repeat, Y direction, number of steps which is number of floors which is 1, and spacing will be 1.6 which is floor to floor height. We need to connect them, so select link step, click on OK. So by this our first floor is created. We don't need this geometry on the face, so just press on delete, click on OK. Now we need to create the cross pressing, so click on Add Beams and connect point to point. Now press escape to end command. Now we will create the remaining floors. So select it like this. Click on Translational Repeat. Number of steps will be 9. spacing will be 1.6 in Y direction. No need to click on link step so that columns won't be repeated. Don't click on it, it's already selected here. Click on OK. And here it is, this is our mobile tower created. The next step we have to do is to assign supports to the model. So let's see which type of support we need to use. Open the PDF file. As we can see here that it's a fixed support. So let's get back to the Staadpro. In Staadpro, click on General, click on Support, click on Create. As you can see, it's fixed. Add. Now select it. Now select the nodes on the bottom. So zoom in. Left click and select the nodes on the bottom only. Assign to selected nodes. Assign yes. So by this we have created and assigned the support to the model. The next step is to add the properties. Press escape to exit command. Now open the PDF to see the properties that we have to use. So as you can see here in the member specification, we have two types of properties. The first property, it is Indian Standard Angle 70 by 70 by 8, and the second property, Indian Standard Angle 100 by 100 by 12. So let's get back to the Staadpro and see how we can add these properties. From here, select property, click on section database. Now select Indian. The type of property is angle. The first property we need to add, it is Indian Standard Angle 70 by 70 by 8. 70 by 70 by 8. Material is steel. Click on add. As we can see, it's available here now. The second property, it was 100 by 100 by 12. This one. Select it. Click on add. Now close this window. Now let's open the PDF file to see to which member we have to assign the property. Now we are here in the PDF file. As we can see that the more loads will be act on the column, so we have to assign larger size property to the column. And in our case, we have this Indian Standard 100 by 100 by 12 is the larger size property, so we will assign to the columns. And the second property, which is Indian Standard Angle 70 by 70 by 8, we will be adding it to the bracing and beams. So let's get back to the Staadpro to see how we can assign this property. First, we will assign the column properties, which is ISA 100 by 100 by 12. So select it from here. As we can see that columns are parallel to the Y direction. So go to select and select beams parallel to Y. We have selected all the columns. Now assign to selected beams. Assign yes. Now we will assign the second property, which is ISA 70 by 70 by 8. So select it. We will assign this property to the bracing and horizontal beams. So we will use a shortcut, go to select and by missing attributes and select missing property. So as we can see that the horizontal beams and bracing are selected. Assign to selected beams. Assign yes. So by this we have assigned all the properties to the member. Now let's go to the next part, which is 3D model. Click on this icon. And here it is. This is our 3D model. Now close it. Now let's start the loading part. So open the PDF file. This is our loading chart. We have seismic loads, dead load, light load, wind load, and load combinations. We will be adding them on sequence. As we did in the previous lecture, same procedure, nothing will be changed. The only thing will change is the values. As we can see here in the seismic, we have zone 3. Response reduction factor is 3, important factor is 1.5, soil type R, structure type steel, damping radius 0.02. So let's get back to the Staadpro. Now we are here in the Staadpro. So click on General, click on Load and Definitions. Since it's a seismic load, then we need to define it. So select Definitions, select Seismic Definition, click on Add. From here, select Indian Standard, which is IS 1893. Now click on Generate. Our zone factor was zone 3, so we will select it based on zone. And as we said that the response reduction factor is it's 3 and here we have 5. So from here select OMRF. So now it becomes 3. And our importance factor is 1 more 5. So select important building. So it's now 1.5. Hard soil and it's steel framing building. And damping ratio is 0.02. Click on generate. Click on add. Self weight factor will be 1. Click on add. Close. Now we have to add the directions, which are positive x, positive z, negative z. So select load cases details. Click on add. Select seismic. First one will be s plus x. Enter. Second one s minus x. Enter. Third one s plus z. Enter. And then s minus z. Enter. Now close this window. Now we need to add factors to these directions. So select the first one, which is s positive x. Click on add. Select seismic. X direction factor will be positive 1 since we are in the positive x direction. Add. Close. Negative x. Click on add. Seismic load x direction negative 1 since we are in the negative x direction. Add. Close. Positive z direction. Select. Add. Seismic z direction factor will be positive 1. Add. Close. And now negative z direction. Seismic z direction factor will be minus 1. Click on add. Close. So done by seismic loads. Now let's add the dead load. Open the PDF. As we can see that here in dead load we have self weight and nodal load. In dead load we will have minus 1 and in nodal load we have 0.2625, which is also in negative. So let's get back to the Staadpro. Dead load is an artificial load, so no need to define it. Just click on load cases details. Click on add. From here select dead load. Shortcut for it DL. Click on add. Close. Now select it. Click on add. First we will add the self weight. Since it's a dead load, it will act on the y direction and it will be negative since it's downward force. So click on add. Close. Now again select dead load. Add. The nodal load, it's here below the self weight. So select nodal load and it will be in the y direction. So it's the value minus 0.2526. Click on add. Close. As we can see that these two loads have a question marks in front of them, so that is mean we need to assign them. So select the first one, assign to view, assign yes. Now select the second one, assign to view, yes. So done with the dead load. Now let's add the life load. Open the PDF file. Here in the life load we don't have self weight, we have only nodal load, which is minus 0.5 kilonewton. So let's see how to add it. Get back to the Staadpro. Since the life load also an artificial load, so no need to define, just click on load cases details, click on add, select life load, give it a name, LL, click on add, close. Now select the life load, click on add, select nodal load, it's minus 0.5, click on add, close. There is a question mark, that is mean we need to assign it. So select it, assign to view, assign yes. So done with the life load. Now as you can see that in the dead load we have give the value minus 0.2526, and which is wrong in the PDF, it's 0.2625. So in order to change it, just select it, click on edit and change it from here. So minus 0.2625. Click on change, close. In case if you put the wrong values, then you just can edit it this way. So by this done with the seismic load, dead load and life load. Now we will add the wind load. Open the PDF file. As we can see here, in the wind load, we need to add intensity. And this intensity is differ according to the height. So for 10 meter we have intensity 1.13, and for height 15 meter we have 1.22, and for height 20 meter we have intensity 1.29. So let's see how to add this. Let's get back to the Staadpro. Wind load is a natural load, so first we need to define it. So from definitions, select wind load, click on add, leave it as it is, click on add, close. Now select type 1, wind 1, click on add. Here we have to add the intensity and height. So for 1.13, height is 10 meter, and for 1.22, height is 15. For 1.29, height is 20. Click on add. Exposure factor, change it to 1. Click on add, close. As we see that there is a question mark here, so select it. Assign to view, assign yes. So by this, done with wind definitions. Now let's do the wind direction. Select load cases details, click on add, select wind load. Now we will name it WL positive X, enter. WL negative X, enter. WL positive Z, enter. And last one, WL negative Z, enter. Now click on close. Now we will add factors to this direction. So select the wind load in positive X direction, click on add. From here select wind load. We have the windward face, factor will be 1, open structure, add. Now we will go to the leeward face, factor will be 0.5, open structure, add, close. So then with the positive X direction, now negative X direction, add, wind load, first we will be negative 1, which is a negative X direction, open structure, add. Now leeward, negative 0.5, open structure, add, close. Then with the negative X direction, now positive Z direction selected, add, wind load, windward in the Z direction, factor will be 1, open structure, add. Now in the leeward will be 0.5, open structure, add, close. Now the last direction, which is negative Z direction, select, add, wind load, negative 1, open structure, add, leeward, negative 0.5, open structure, add, close. So by this, done with the all directions, which is positive X, positive Z, negative Z. 1.5 minus 1 minus 0.5, 1.5 minus 1 minus 0.5. So by this we have added all the loads. Now the last load remaining, which is the load combinations. Let's open the PDF file. Here we have our load combinations auto-generated as per IS code. So let's get back to the Staadpro. To generate the load combinations, select load cases details, click on add. From here select auto load combination. From here select the Indian code, which is Indian code. Now click on generate loads, click on add, close. So by this, done with the loading part. The next part is analysis. So to do the analysis, click on analysis and print, select all, click on add, close. Now go to analyze, run analysis, save. As you can see that we have 0 errors, 1 warning and 1 note. The warning might be the UBC IBC. We will see how to eliminate it later on. Click on view output file, click on that. Warnings, selected, UBC IBC, the same warning which we got in the last project. Now let's click on result. From result we can see the reactions, moments, shear force and total weight of the structure. As we can see here, the actual weight of the structure is 29.521 kilonewton, and that means the steel member which we assigned, their total weight or total quantity for both will be 29.521 kilonewton. Now done with the analysis part, so let's close this report. Now let's start the design part. Now we will start the design process. So click on General, click on Design. From here select the Indian Standard Code, which is IS 800. Now click on select parameter. Move all of this parameter to the other side. Click on this double arrow. Now from here we need only yield strength of steel, which is FYLD. Selected. Move it to this side. Click on OK. Now we need to define the parameters, so click on define parameters. Here we need to add the grade of steel, so we have 415, 500, 250. In our case we will be using 415, so type 415 000. Click on add, close. Now click on comments, select check code, add, select take off, add, close. Now scroll down, this question marks, so select the first one, assign to view, assign, yes, check code, assign to view, assign, yes, steel take off, assign to view, assign, yes. Now let's eliminate the UBC IBC warning. Go to the Staad editor and click on it. Here in the positive X, click here, enter, type perform analysis. Enter, change. Now select it, Ctrl C, positive Z, click here, press enter, Ctrl V. Now save it. Close it. Click on Analyze. Run analysis. As we can see now, we have 0 errors, 0 warnings and 1 note. Now click on View Output File. Done. Now click on Result. As we can see that we have 2 more options added here, steel design and steel takeoff. Select steel design. Now check whether all the members pass against the loads we apply. As we can see here, now it's pass. So the second thing we need to check is the total quantity of each member. So scroll down. As we can see here, for the first member, which is ISA 100 by 100 by 12, total length is 64 and weight will be 11.1111. And for ISA 70 by 70 by 8, total length 226.08 and the total weight will be 18 and total will be 29.521. This is which we use for the pressing and horizontal beams, and this is what we use for columns. Now let's close this window. Now let's talk about post-processing part. In post-processing, we will check reaction values, shear force values, moment values and displacement. So here, next to modeling, click on post-processing, apply, OK. First thing we will do, just press on Control button and scroll forward by using the scrolling button in your mouse slightly. Now as you can see, the green and the gray colors. Here we have the node beige. If you click on it, we have reactions and displacement, and here our beam beige. If you click on it, we have graphs, unity check, stresses, forces. First we will talk about node beige. Selected. Now click on reactions. As we can see here that our reactions are overlapping, so all we need to do, just click on this selection tool, select text tool, click on it. Now just drag and drop. So these are our reactions and moment values, and from here we can select the type of load. For now it is seismic on positive X direction, so you can select wind load. As you can see, the values will be changed. Now we will check the deflection. Just click on this icon, which is deflection icon, left click. As we can see now, here we have the deflection. Deflection will be maximum at the top and will be minimum at the bottom. And dead load we will have slight deflection, but in wind load it will be more. Now to remove the deflections value, just click on the icon once again. Now let's click on beam page to see the shear force and moments. So here we have the beam wedge selected. Now press Ctrl and the mid button of the mouse, slightly scroll forward. Now to zoom in, release Ctrl button and just zoom in. Now we can see the bending moment. Here we have the point of contraflexure in which moments will be 0. Here we have the positive bending moment and here we have the negative bending moment. You can check for each member individually, just click on it. As you can see now, it's selected over here. You can also enlarge this to see the shear force and moments. You can check for each and every member. Now let's get back to that page. Click on post processing, select beams. Now done with moment, let's check the shear force. From here you can select shear force in X direction. As you can see that, it looks like a chocolate. This one represents the shear force in X direction. Now click also on FY, you will find it shear force in Y direction. We have also Z direction, and here we have torsion, and from here bending moment in Y direction. Now let's see the maximum stresses. Click on stresses here, and this is our diagram. Just enlarge it, press on Ctrl and zoom forward. Now remove Ctrl to zoom in. As you can see, this is our stresses. So in order to see the maximum stress, just click on post processing, beams, stresses, make it isometric, and then zoom in. So select the member. Now click on display legend, display corner, and then close it. We can see here the maximum stress, and this is the minimum stress, and from here you can see the beam number, which is 120. So enlarge this. Here we can see maximum stresses, so you can check it from here. Now we will talk about the last part, which is the animation part. Click on post processing, click on animation, select deflection, click on apply, click on OK. So here we have the wind load in Z direction. So if we change it to dead load, we will see that the movement becomes vertically. Same with live load. So if it's moving too fast, as you can see here, just click on post processing and Control and then zoom out slightly. Now again click on animation, deflection, apply, OK. So that's it for this tutorial. Now click on modeling, click on fire, save, yes, save. In the next lecture, inshallah, we will do army tower and sniper tower. So that's it for this one. I hope you enjoyed this tutorial, and if you did, then please like the video, and if you didn't like it, you know what to do. Any sincere feedback is appreciated. Anyway, as always, I would like to say thank you for watching, and I hope you have a wonderful day. See you in the next week, inshallah. Before I end this video, let's enjoy watching a short video about beautiful places in India.